All right, we'll kick off. Welcome everyone. I'm Brady, this is Hendrik. He's going to start the first half of the presentation and talk about extensions with Python packages and a whole bunch of cool experiments. And then I'm going to give a sort of secondary talk halfway through, which will be more about sort of packaging and building on GitHub and how to automate a whole bunch of extension development. And hopefully you'll find it interesting. So we'll hand over to Hendrik.
Yo, hi, welcome everybody, and I hope you had a great conference so far. Right now we will talk about add-ons in Blender. I will quickly talk a bit about my recent add-ons. We will go over some dependency basics. We will build a simple extension, and then I hand over to Brady for add-on distribution. So there is this amazing new extension store where we can host add-ons. That's about what we will talk about today. There's also themes, which is not covered right now. I have so far 5 published extensions in the add-on store, and I want to talk about 2 of them right now. The first is a types importer extension. If you haven't heard about types, it's a modern typesetting language, very similar to LaTeX, but a bit more modern, written in Rust, super fast, and you can render all kind of like equations, formulas, tables, whatever fonts, whatever typesetting you want to do. So this is how it looks. This is how it looks rendered. And I thought it would be amazing to have this kind of control of fonts about equations also in Blender. So I've written this extension which packages types as a Python package and then makes it accessible via Blender. So I have here the, can I see the mouse? Okay, or I can just show it. I have here the code, and when I press enter, then this will run the code, and it has multiple options of importing these sequences. So for example, there's the option to, which you can see right now, it's getting imported as a mesh. You can also import these as curves, and I'm hoping also to support grease pencil in a few weeks. And the way it works, it's taking all this content, puts it into an SVG, and then this SVG is imported into Blender. And because it's an animation software, we can also do these kind of animations with it. Here's also a multiple step animation, and so this one is aligned with at the equal sign. If you want to learn more about how to create an animation like this, I've also a full YouTube tutorial on how to align all these elements. There's even a small tool with operators to make the alignment and the follow the curve process as easy as possible. So this animation takes about 15 minutes to create. Okay, next problem was that for this types importer, I needed SVG import, and the Blender internal SVG importer is amazing, but sometimes it's missing some features. For example, here we had, so on the left side, this normal import sometimes misses colors, then the curves are not always correctly imported, so there's another Python library that I used for importing and processing the SVG, which makes this a bit easier. Another project of mine is about Euclid's geometry. So this was this famous Greek mathematician who asked himself about 2,000 years ago, how can we make the best possible 3D software? And he came up with this concept, the default cube. But maybe also some other thoughts came before that. And there's a video which was published yesterday by 3blue1brown. And he made some guest videos, and I had the chance to have to make one of these animations in Blender, and I can really recommend watching that as well. Okay, but now we come to the extension store, and first I will start with some statistics. We have currently 553 add-ons, and importantly, we are interested in the Python packages, so the add-ons that use Python packages. 40 of these add-ons use currently Python packages, and that number doubled in the last 5 months. So the source of this is from the Blender team. I got this manifest JSON file, and I was doing some analysis on them. So in total, these 40 add-ons use 208 Python packages, which you can see here next to each other. And yeah, so 40 add-ons, but 208 Python packages. And that's the case because one add-on can have multiple dependencies. So here we have microscopy nodes, which has a few add-on, a few dependencies. If you haven't seen the talk, I can really recommend one of the highlights the last few days. And these Python dependencies are also called wheels, because you don't have to reinvent the wheel if you're using Python libraries. You can use these instead. Next, I want to show you some of the wheels, some of the Python libraries that you can use. The most commonly used, I think there's over 10 extensions that use Pillow, and that's an image processing library. You can use it, for example, if you want to load an image, if you want to blur an image, if you want to save an image. That's a lot of possibilities there. Then there is Network X for the creation, manipulation, study of networks, and another one, for example, is Requests if you want to load data into Blender from the web. Okay, and there's also now the case that some add-ons share the same dependency. So we have now Pillow, and we have, for example, molecular nodes, but also microscopy nodes, which both use this package, and it's installed in the same environment. So all extensions are always using the same dependency. If we now map all these extensions with all the dependency, we get this graph here, and you can see that, it's a quite big network of add-ons and dependencies. There are also some unsolved challenges with the extension system. So, for example, what if molecular nodes wants to use Pillow version 10 and SciBlend wants to use version 11 of the same package? So then there's like a collision. We cannot have both packages installed at the same time, and this could potentially cause problems. There were, I think, no reported problems yet, but it could be a problem at one point. Also, another thing is that Blender itself also ships Python packages, Python dependencies by default, and add-ons are also sometimes relying on dependencies which are not the ones that ship with Blender. This could also cause conflicts, but again, we don't know how big this problem is or if it is a problem. I've also had a look at this versions.cmake file in the Blender repository, and you can see that in April 2025 we had these dependencies on the left, so NumPy 1.2.6 that didn't change, but then, for example, Charles set normalizer was updated, and some other libraries also got updated. There were some additional libraries, and this is how it looks. Okay, if you want to have a look at this yourself, here is a link with a blend file. And I also want to quickly show you how this graph was made. So these are two grease pencil objects. On the left side, there's a Jupyter notebook, which reads the data from the JSON file and then places these elements at the right positions. Okay, now we want to go on with extensions, and we want to build an extension. There was already an amazing talk about this yesterday, import BPY, where you find all the details about the libraries that you can use, or all the operators, how you can define them. And this was using Visual Studio Code, the Blender Visual Studio Code extension. What I'm right now using for prototyping my extensions is PyPi Jupyter. It's still a prototype, and it's made by Sophos. So thanks a lot for the implementation at this point. It's an amazing add-on. And I will quickly show you how to install it. So here is a link with a zip file. This is the extension. You can download the extension, then copy-paste this extension here into the Blender viewport. Then you wait a bit. You find this new panel. You say Start Jupyter Kernel. The Jupyter kernel is starting. You can open a notebook and run your code, and you will get this interaction. And this took like from installation to ready to play in about 30 seconds. If you want to try it, it's currently available for macOS, but again, it's an early version, so you might run into problems, but for me, it runs already quite stable. Okay, and there's also the option to run these, so the Jupyter kernel is currently controlled by Blender, and you can also go into other coding environments like Cursor or Visual Studio Code and run your notebooks there. So here is the same thing again. So I'm creating a new Jupyter notebook. It asks me, okay, do you want to install the Jupyter extension? Yes, we install this one. After a few seconds, it's installed, and I disable the auto launcher. I start a Jupyter kernel, copy the kernel URL, select the kernel in the Python notebook, paste the URL, select the kernel, and now I can again print content. Okay, and now if you want to go on with development of add-ons, I can really recommend enabling the Python tooltips. You find it in preferences, and then when you hover over any things in Blender, you can find these elements here. And here's another screen recording. So yeah, first enable the tooltips. Then I hover over it, and here I can also make now screenshots. And go into my code editor, paste the screenshot, and now scrape the content of the screenshot and tell, in this case, that's a large language model, get the content and run the cell, and it immediately updates this value. Okay, so the way I'm building add-on development is I build minimal code snippets. And this is like very with caution. Sometimes I'm also using large language models to help structure these code snippets. And then I combine these minimal snippets into extensions. Okay, and so I want to have as much control about for my LLMs as possible. So I'm defining custom rules how this autocomplete should work. So this is a very long markdown file where I can here in the first place say, okay, my custom instruction is don't be overly verbose, or you're working in the Blender node system. Then here is when you want to select nodes, use this code snippet. If you want to have the active node, it's done like this. Then there's also custom rules for the operators, how operators work. And with all this in place, I can start drafting and thinking about ideas of how to build my extension. And the first thing that we will now try to build is a blurry HDRI extension. So by default, it's not possible to blur HDRI backgrounds in Blender, and we want to use now the image library PIL to create this blurry HDRI thing. And so first we have to think about how do we want this process to be. And so my thought process would be, okay, so first we need to select the node. Then we need to get the file to the path. Next, we want to blur the HDRI. Next, we want to save the new image and load the new image into a new node. And this can be done like this. I hover over this field here. I make a screenshot. I paste the screenshot into my IDE and tell, in this case, the LLM, get the currently selected node and print the image output location. When I run this one, then I get this code. And after checking that it's doing what I'm actually wanting to do, it's bringing me this one. And the nice thing about Jupyter is also that you have the code and the output very close together. So in the normal Python scripting environment, you would see this probably somewhere else, but here you can see, okay, this is exactly the thing that we wanted to have. Now I want to use the Python package pillow in order to blur this image. I can also say, yes, that's how I want it to be. Now I want to save this new blurred image. I also want to create a new node, a new environment texture node, and place this newly created node into this new image into this new node. That works also as expected, and when I run this one, I actually get my new node in the environment, and I can select it, and it's actually the same thing, but in a blurred way. Okay, but I forgot to mention one thing. We also have to install Pillow because it doesn't ship with Python itself, so with Blender itself. So we can run this also in a notebook. This is this pip install command, pip install Pillow, and now we have the latest version of Pillow. So the script is now complete. It's 29 lines of code, and we have, in theory, a working extension. But before we publish this extension, we now turn this script into an operator. And again, our LLM is aware about how operators work. So next I tell, okay, I want this script now to be an operator. And I also want to have a small slider so that I can say, I want to have this kind of blurriness in the radius parameter here at Gaussian blur, and I want a pop-up window for this. And this also works quite well. If after checking the code, you can see, okay, now I have this new operator, and it opens this window here. And I have a first version. I can do it again with another parameter, and I have an even blurrier version now. Okay, now the operator is complete as well. And now we come to the next step, and this is to turn this operator into an extension. And for this, we can go to GitHub now, create a new GitHub repository, in this case, blur HDRI, do all the things that you normally do with by initiating the repository. And now I have a template that I'm always using for my extensions. I'm just pasting it here. And in this template, I have an init file. This is where the operator will live in. Then I have the Blender manifest file. Here I define all the metadata for the extension. So, for example, the name of the extension, the maintainer, the website where you can find documentation. And then there is the build script, and this is the part where I'm defining the Python packages that I'm using. So this build script, it's actually written by Brady, will take care of all the Python packages. With this done, I can now run a command to build the extension, and when you see in the outlier, you find now that there are 4 new builds, and these build files can now be uploaded, or zip files. These zip files can now be uploaded to the extension store. So I'm opening it, I'm copy-pasting it there. And okay, this is already present, but now I find this field. You can find the extensions on this link. And now we come to extension publishing. So this is the publishing page. I create a thumbnail. I create a small demo video on how to use this extension. And next, I submit for all platforms. So we have now 4 files, and I can press 4 times upload new versions, drag and drop these new versions into the page, and then after a few days you get an email, okay, all good, this can be published, and after a few more days you get this feedback, great contribution, UX is terrible, and some ideas on how to improve this for future versions. Okay, with this, I want to thank you.
So I'm going to talk for about 20 minutes, and then we should have around 10, 15 minutes for questions for both of us, for people who are interested. So all of my slides for today are available, which is exciting. I'll put up a QR code in a second. But I'm going to talk about extensions, bit of a not so useful table of contents, but yeah, the slides are available. That links to basically this little thing, which is a blog post as well with some extra info, which I will also continue updating after the talk. And so that'll link to everything that I mentioned. It'll also give you spoilers for the talk, so don't look too far ahead. But I'll start with who am I. I'm Brady. A couple of years ago, I gave a talk about visualizing viruses. So I started my life doing my PhD as a molecular biologist and a biochemist, and I could just press play and play my entire talk from a couple of years ago. But I recommend going back and giving it a watch. I think it's quite good, and it shows off sort of what I do. And pretty much since this point, I've been doing nothing but building and rebuilding this add-on. I've rewritten it from scratch 2.5 times since this point. So I spent a lot of time building one particular add-on, which is molecular nodes. And I'm sort of going to give you some tips about what I've sort of found to help speed up this process, make it more robust. Because molecular nodes is used by a bunch of animation studios doing scientific animation. It's also used by individuals, it's used by scientists, so there's a bunch of different use cases that I'm trying to cater towards and make sure it's as robust as possible. But it basically brings molecular data in, it's mostly geometry nodes based, and we do all sorts of fancy stuff under the hood. But I'm not going to really talk much about the add-on. Again, the talk's there if you're interested. To sort of prove my chops, I've got the add-on, but I've done the crazy thing that you can also install my add-on as a Python package. So if you want to install my add-on inside your add-on and ship it as a wheel to the extension platform, you can do that. I obviously wouldn't recommend it, but this is so it can perform parts of like automated analysis and rendering pipelines for different scientific institutions. But you can run through the script, and if I run this script right now, this is the result. So we download DNA from a scientific database, we do our rendering under the hood, and we do all this sort of fancy stuff. So molecular nodes has a lot of sort of moving parts, a lot of stuff going on. It's one of the larger extensions on the extensions platform because of the number of packages that ship with it. One of the ones I just want to highlight for people who are interested is something that I've created over the past like 1.5 years, data BPY. So everything I do is NumPy. And if you're ever setting and getting attributes from meshes or point clouds, that sort of thing, you might want something that acts much more like a NumPy array. So I've created a Python package which wraps objects and makes that a bit easier to do things like this, where if you just want to update the first 10 vertices of an object, you can do it with sort of NumPy style indexing for getting and setting attributes. But I just sort of want to... I find it incredibly useful. So a couple of other extensions have started using it, and I recommend giving it a look, and lots of feedback welcome. But this is mostly a talk about building on GitHub. This is molecular nodes on GitHub. We're now at like 30 contributors or so, over 1,000 stars, which is exciting. We've got a bunch of scientific papers that use it to create images. It's forming parts of pipelines, all that sort of stuff. But I want to talk about why you want to build on GitHub. Obviously, I'm not paid at all by GitHub. I've just benefited a lot from using it. Other platforms exist, like Codeberg, etc. I just have spent all my time on GitHub, so this is the one I know. It gives you some free file hosting within reason. If you start uploading terabytes of data, they'll send you an angry email. But it does give you basically, if you're a free open source project, so if you just have your publicity set to public, then they give you free compute, they give you free storage, again, within reason. If you start mining Bitcoin, they might get a bit angry. But it also gives you increased visibility. So there's a bunch of people who use the extension and also help develop the extension because I'm building in the open and people can look at it. And yay, over 1,000 stars, but that is obviously not guaranteed. This is what I spend all of my time looking at, and I'll sort of go into what's going on here. But this is the automated testing pipeline. So every time I push a change to GitHub, it runs through a gauntlet of tests, which I'll sort of detail a little bit. I won't go into the particulars of running any tests. I'll link another talk in a minute. But every time I push a change or update anything or fix a bug, I run tests against all the different versions of Blender that I want. So currently I have it set up to scrape daily builds and also 4.5, but you can test back to whatever. I also test against the Python installable BPY. And it also, I've got it set up to automatically download all the required wheels, bundle that up, and send it to the extensions platform. So I don't have to manually do that dragging and dropping that Hendrik was showing earlier. So this is all now an automated process. The Spencer was meant to give a talk yesterday. He got norovirus like 2 days before the conference, so he didn't give the talk, but he is going to record, but that's a link to his slide, and his recorded talk will be uploaded at some point. He's going to go into the particulars of how to test your add-ons. Again, this is all linked on that one link at the start. So I'm not going to go into how to write tests. If you're interested, look at my repos. I've got a bunch of testing files there. But what I am going to talk about is, okay, I've sort of mentioned this thing of GitHub Actions. And so every time I'm pushing a change up to GitHub, a GitHub action runs. And so what a GitHub action is, it's just servers provided by GitHub. Again, free compute for public projects. Gives you access to actual hardware, so Mac, Windows, Linux. If you, like, I certainly don't run around with a Windows machine if I can at all avoid it. But this gives me testing hardware to test that on. Mid-power machines, no GPU. But you can, a really, really, really useful feature is you can set up your own machines to run as GitHub Actions. So my computer way back in Australia with a nice 3090 sitting in my friend's closet, every time I push a change up to GitHub, it sends it to Australia, gets rendering and ensures everything's working as it can, and then sends the results back to me. And so it has this really nice automated setup. I'm not going to spend too much time on particulars, but I'll just sort of, this is what a GitHub action looks like. All you need is a YAML file, which is just a horrible way of specifying a series of steps. I hate YAML with a passion, but alas, it is what we're stuck with. And this basically says, whenever I do anything to the main branch on GitHub or any pull requests, then run some jobs. What are those jobs? Well, up to 4 jobs run at once. I'm requesting Blender 4.5 and the latest daily build from the Blender website. So whatever alpha features are coming, this will be tested, and it gets tested against Linux, macOS, Windows. So there's 6 different tests that are run in a matrix of all of those different changes, and you can just add in 4.4, 4.2, 4. If you want to test back even further. This little thing, if ever your actions explode, you forgot this line, it just won't do anything and complain, so I'm just highlighting that. This is my own little GitHub action that I've set up as a convenience, so if you want to run on your platform, all you need to do is include these 2 lines, and it will then scrape from the Blender website and download the requested the requested Blender version and make it available on your GitHub runner. And so all I need to do is include those lines, and now I have Blender installed on my GitHub action runner, whether it's Windows, Mac, Linux. And all I can then just say is Blender, install my tests, run my tests, report my tests, and say, okay, did anything fail? Am I getting good code coverage? So again, I'm not going to go into particulars of how to write those tests. Check out Spencer's talk for that. So why would you want to write YAML? If you can avoid it, but we have to write YAML. So 5.0 is coming out, which is so exciting, big changes. But if you haven't already tested your add-ons against any of the daily builds, you may not have noticed that if you ever use Blender Eevee Next, it breaks, because Blender Eevee Next is now Blender Eevee. My automated testing caught this like 4 weeks ago, and I was like, I can change that. Bing, bong, done. Now I know when 5.8 comes out, that part is fixed. Compositor no longer has used nodes, fix that. Set curve resolution, this wasn't an issue with my add-on, this was actually an internal issue inside of Blender that I managed to pick up and report and is now fixed. And this one, 2 days ago, I got an email from GitHub saying everything is exploding, it's failing. And what I wanted to do was, it's a little bit of a treat. This is the pull request I'm making to fix it. I'm just saying, okay, here's the issue where it fails. This is the error I was getting. And then my fix is in here, and I'm just going to go boop, and live, we're just going to fix that. And so if I wanted to, I could then go onto my main GitHub, I fixed an issue, and I could just click a button, and it would trigger a build where about 10 minutes later, it would send it off to the extensions platform, already, my extension's ready to go for 5.0. And we've got, so those are just the highlights from the past couple of weeks of things that I didn't directly cause in terms of bugs, which obviously I've done plenty of that myself. But that's just 5.0 breaking changes. But I think something that a lot of people are really interested in is about distributing on GitHub, and this is something I've been trying to tell people about for the past few days. So old school, You may see people uploading extensions to GitHub. Basically, they're like, oh, just zip my repo and install. Sure, that's fine. But you don't really get like control over versions very nice. And it's never clear where updates are available, all that sort of stuff. Or you could also package zip releases and put it on GitHub. And again, people have more manual control, but you don't get this auto updating that the extensions platform and the extensions infrastructure provides. So instead, we can do it the hip, new, cool, and fresh way with extensions, patented, where you host an index.json somewhere, and that points to files. And that's it. That's how you host your own extensions repo. So Blender is hosting an index.json, and that points to files. And then Blender has that sort of registered, and then that's how you get updates and you install stuff. And so we can just do that ourselves anywhere we want. Now, I'm going to show 2 different ways to do that live. One of them, we're going to do a live bug fix. So if anyone wants to install my cool and hip new add-on that I'm going to show on the next page, it's got a bug in it, and then I'm going to fix it, and then immediately you're going to get the fix, which is very exciting. But we just host the index.json on GitHub, and then basically GitHub does the file hosting for us. And that's pretty much all we need to do. And so you can do that in a single index for a single add-on, so you subscribe to a single add-on, or you can have one repo, which then looks at a bunch of repos, which I've got an example for later, where whenever, basically I just have it set up that daily an action runs, it scrapes all the new versions, uploads them, and so daily users get access to a whole bunch of new add-ons, which maybe they're not on the extensions platform because they're massive or because you're beta testing, if this is really great for sort of testing out new versions, or it doesn't meet one requirement or another, you can just do your own hosting. There we go. So we're going to do a live example. If anyone has their laptop and Blender open, you can go to github.com, Brady Johnston /monkey madness. And we're going to install this new add-on, and I'm going to show you that there's a horrible bug, and then we're going to fix it, and live coding has never gone wrong in my life. So we're going to get Blender. I think I already have, so I'm already subscribed to Monkey Madness. I'll just bring that back up again. So if I go to this repo, let me pull that up again. So GitHub, Brady A. Johnston /monkey madness. And so that will basically provide you in the README with a little link. And to get the add-on, all you need to do is copy that link in your get extensions. You just add a new repo and you paste in that link. And now you are subscribed to my Monkey Madness add-on. And so if I go into here, we've got Monkey Madness, so we've got our add-on, it's all good to go. And so what does my amazing add-on do? We click the button, we get a monkey. Oh my God, wait a minute, that's not a monkey. And so we've got a horrible bug in our Monkey Madness add-on in that sometimes we don't get a monkey. All right, let's do some coding. If I go, Monkey Madness. We go into our operator. Oh no, someone placed this bug here. Let me comment out the bug line, uncomment. Hooray, it's done. I should run tests. Obviously, if you do any kind of good development, you would put a test in first, then you would fix your bug, and now it passes the test, blah, blah, blah. We don't have time for that. We're on the clock. So hopefully some people have downloaded Monkey Madness. And I need to, at the bottom of this Monkey Madness repo, I've got 2 commands here. One that builds Monkey Madness, and then one that generates an index.json and a HTML. And we can see up here, we've got our repo thing, but we've also got a package little .zip. And this is sort of where my add-on's living. This isn't the ideal setup. This is just the simplest setup. And so what we're going to do, we're going to remove, we are in the wrong. All right, so I just deleted the old Monkey Madness. I'm pasting these 2 commands in. I've built a new Monkey Madness. New monkeys. And now I'm pushing that, Tip for your branch. Uh-oh. I didn't update my README. Oh, Jesus. It always goes wrong. Let's just ignore whatever's on GitHub. This has never gone wrong. Just push to main. So I've pushed my new built add-on up to GitHub. And ideally, I would have some tests running up on GitHub before I did anything. But what's going to be happening here is that it's just going to quickly build a GitHub page and then push that. And after this goes green, it should then be available. Oh my God, no, I didn't bump the version. Uh-oh. Oh, live coding, you know? Yeah, exactly. Uh-oh. Oh my God. I just got a new computer and it's a UK keyboard instead of a US keyboard, and I just can't use a computer, it turns out. Oh no, I didn't need to do that. Jesus, I'm so sorry for this. This never happens, I swear. All right, now there should be a new Monkey Madness 1.4 pushed up to GitHub. And then once this is done, which should take about a minute, then it should be, if you look at Monkey Madness in your extension, there should basically be an update that will appear in a minute or so. While that's processing, I'll sort of go back to this and talk about instead the idea of your personal extension repo, where you build and release add-ons through automations, and you can do multiple add-ons, and it's much more organized. So say you're someone who has a bunch of add-ons, you put it up on Gumroad or this, that, and the other, but you'd rather people be able to subscribe so that they can just quickly get updates like this. And I've got a version of that. Where if we go to that, let's check on our Monkey Madness.
It's there, but the trolls is also still there.
Well, look, I updated my Monkey Madness. We're getting some errors. I think you get the idea. Our live coding has entirely failed. But, you know, that's the essence of live coding. The idea, though, is that the new file is available to someone. If they weren't typing on a brand new keyboard, live being recorded, it would work better. But a version of that where there are multiple add-ons that are able to be subscribed from a single index. So this is, again, if you just copy and paste that, you can subscribe to these like series of add-ons that are then updated and available to you whenever I sort of push new updates. If I go to the repo, again, all of this is linked in that initial sort of thing that I linked at the top. There's some explanations about what's going on and how I've sort of got this all set up if you want to look through it. But again, all it's doing is that once every day, it goes to any assets that are in any repos that are listed in this text file. So this is all I need to do to add. If they have published a new version on GitHub, it'll download it, index it, and then update the website. And when you then subscribe, you're not downloading from this repo, you're downloading from the original GitHub release location, so everything's much safer and works sort of how it should. And so this way you can just very quickly add brand new repos, and you can have one sort of centralized repo if you yourself created a lot of add-ons, or maybe your studio or whatever creates a bunch of tools. You can quickly build and update and release your own add-ons. So Monkey Madness needs some improvements, but let's finish. And so this is just going through this YAML. So again, another GitHub action for this sort of group repo. So in this case, I'm not testing on a bunch of versions. I'm just doing macOS. And I'm just downloading the latest version of Blender, again, using my nice little GitHub action that just requests whatever's the latest version. So currently 4.5. When 5 gets released, it'll be 5. I run a nice little script that does some downloading. We build our extension repo. I use Quarto to make websites. You can use your static website renderer of choice, or just use the Blender itself, which also generates a nice little HTML, which is convenient. And then, yeah, that's that link again where you can distribute your own extensions. And so that takes me almost perfectly to 20 minutes. But I want to mention Blexed. So again, this is linked all on the website, all on the slides. But this is a project by Sophus, who was mentioned earlier as well, to try and help with a lot of this sort of thing. So it's in early versions at the moment, but it's going to be a nice little command line utility to source your wheel files, set up template tests and YAML files and all that sort of thing. And so if you're interested, go check that out. But yeah, thanks very much. Again, slides are linked there, and we've got a nice little 10 minutes for questions. So thank you. We've got a bunch. We'll go, I saw you first.
I have a question. When I'm writing in addons, sometimes I have some things implemented in geometry nodes besides the Blender files. How can I maintain them on the GitHub, the version? Because when you try to merge raw data,
Yes.
you don't overwrite it.
Yeah, so the question was around like version controlling geometry node trees, basically. I have absolutely no solution for you, other than currently, so I ship like around 50 or so different geometry node trees, and I just have to keep the git commit history as linear as possible. It just can't handle merges or anything, or I'm in there manually trying to fix stuff up. I wish there was a better solution.
Maybe we can export it, I don't know, in the JSON some sort of, and then...
Yeah, so there's a couple of solutions that exist. There's like Node to Python, geometry script, and a couple of others which sort of do this. I find them overly verbose, when one node tree will become several thousand lines of Python and is of no use to me for version control. So I'm just, I have all my testing infrastructure in place, and so I know if I've accidentally changed a node tree somewhere that something's exploded. And so tests is a good way to sort of know if something's gone wrong, but currently I don't know of a good way to try and version control node trees. So in this discussion, we were just having the special interest group earlier. So that's sort of it. And currently, there's no solution. I'd love there to be a solution. So for my, again, I didn't go into any details, but for my testing, I basically add a node tree, add a node, and then apply that node tree, and then test to see what vertices ended up at the end of it. And so I don't do any fancy testing. I just know, currently there's 51 vertices where I expect 50 vertices. And so then I go into the node tree and be like, okay, what's going on here? Like, what's going on? And you can also have render tests where if you render something and you have two PNGs and you're like, okay, this PNG should look like this and now it looks like this. My tests tell me something's wrong. I have a look. Okay, there's an extra vert over here, an extra face. And then it's up to you to sort of dive in and find what's going wrong.
Thank you.
Yeah.
Cool. So I got a two-part question. Before that, I find your fear of YAML slightly irrational.
Look, yes, it's understandable.
My company, we use YAML for a whole bunch of stuff. Anyways,
I haven't written enough of it yet, so,
I have a question about the DPY Jupyter.
Yes.
My company, our solution really uses a lot of Jupyter stuff, and one of the things we're trying to do is integrating with some engines, Brady engines, to do operations exactly what you showed. So very interesting. But quick question. So you used import BPY, that's great. Does that also include dmesh?
I think it should. So it's implemented by Sophos. So I think I forward this. Yeah.
Yes, it's as if you wrote it in the script editor.
Okay, cool. The second question, I might have misheard you, but correct me. That is only supported on Mac OS at the moment?
So the build process is still weird because it's using a prototype of Flex, which I'm also making. It does work on everything. It's just right now it's kind of you have to go and build it yourself. There should be decent, we can also talk after.
Sure, yeah. I mean, if we have to build it ourselves, that's fine. It's just that our tech stack is on Linux, so.
Yeah.
No,
Me too.
Sure.
Yeah.
Cool. All right. Thank you.
Yes.
So in the first half of the presentation, you showed you generate 4 wheel files, one for each platform.
Yes.
Can you use that none-none to tell that it's a platform-independent package and generate just one and publish in the extension as well?
Yeah, so Blender does that automatically.
Okay.
So if you use the Blender command, if you, well, not that command, but the other extension command to generate a, there's a -- split platforms, and that should automatically go in and split it if it needs to, and not split it if it doesn't need to. Yeah, so Blender handles that.
Another question regarding versioning. So if for some reason you make a mistake and you still, after all the tests, you have a bug, and someone updates the extension, can you roll back to a previous version somehow?
I mean, if you're controlling your own thing, definitely you can do whatever you want. Whether that's a good idea or not is always a, so.
I meant in the Blender interface. So you click update, you get the new version, but then it has some bug. You cannot.
There's,
Right. Okay.
yeah. So if it's on, say, the extensions platform, that serves you just the latest updated version. A user can go in and manually download it. When you're generating your own, you can generate with every possible version. But I don't know if there's an option to deliberately install a previous version. You would have to yourself just delete or obliterate the buggy version, and then the most recent version becomes the less buggy version. Yes?
It's not a question, but in our studio we have a practice that may helps forgetting to write down the version update into and then we inject the version from the GitHub tag.
Yeah. So that's it was a comment around my failed live coding where I didn't bump the version, where you can do that via the GitHub tag. Yeah, and so that can become just part of the build process. And so if it wasn't my janky little monkey madness repo that I tried to keep as simple as possible, yeah, you could have something set up around exactly that. All right, I think we're good on questions, great on time. So feel free to reach out to either of us about any further questions, and thanks everyone for coming.